Oh hey, didn't see you there. Welcome back to another episode in Andrew Does Chemistry. In today's lesson, we're going to cover bond types. Come along, I'll show you.
Andrew and friends do science!
We're glad to have you back. Today, bond types, we're going to cover 4 different bonds. Ionic bonds, metallic bonds, covalent bonds, and network covalent bonds. My helpful assistants, Zeke and Joanna, are going to help explain them.
Before we talk about what each of the bonds are, let's talk about the differences between polar and nonpolar and what it means. Polar means that the elements that make up the molecule have an electronegativity difference of greater than 0.5. And polar substances dissolve in polar substances. There is a difference in electron density throughout the molecule. On the other hand, nonpolar means that there is an electronegativity difference of less than 0.5 between the elements that make up the molecule. It dissolves in nonpolar substances and has similar electron density throughout the molecule.
Now, let's talk about what ionic bonds are.
Ionic bonds are the bonds that exist between metal elements and nonmetal elements in a molecule. In this example, we have Na and Cl. We know that Na has 1 valence electron while Cl has 7 valence electrons, and that the Cl completes the octet by grabbing an electron from Na, and therefore completing the transfer of electrons. Note that this is a complete transfer of electrons, which is different from other bonds. And because there is a complete transfer of electrons, this molecule is polar since there is a difference in electron density throughout the molecule. In addition, some characteristics of ionic bond is that it exists in a lattice structure, sort of like a cube, that are arranged like this. And it dissolves in water, and after it dissolves in water, it becomes ions. In this case, it would be Na plus and Cl minus ions. It has a high melting point, and it conducts electricity in water.
The next bond is the metallic bond, which is between 2 metals. Because metals lose electrons very easily, they create a sea of electrons when they bond together. And because there's a sea of electrons, this makes it easy for electrons to flow through and conduct electricity, which is why metals are very conductive. In addition, the sea of electrons helps it to be malleable because this helps metals to be less rigid in the compound. It also does not dissolve in water. The next type of bond are covalent bonds. A covalent bond, which is also called a molecular bond, is a chemical bond that involves the sharing of electron pairs between atoms. These electron pairs are known as shared pairs or bonding pairs, and the stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. Covalent bonding is between a nonmetal and a nonmetal. It is not conductive and has a pretty low melting point. In addition, it dissolves in H2O but is usually less soluble than ionic bonds. It is also not conductive even when it is dissolved in water. The next type of bonds are network covalent bonds. A network solid or covalent network solid is a chemical compound in which atoms are bonded by covalent bonds in a continuous network extending throughout the material. In a network solid, there are no individual molecules. Therefore, network covalent bonds are extremely hard to break and are insoluble. Network covalent bonds have a high melting point due to its strong bonds. They are also brittle, and some examples of network covalent solids are diamond, silicon, and graphite. They are not molecules, but instead giant networks, just like its name.
All right. Now it's time to put your knowledge to the test. What bond type could C make?
What do you mean? That's not a bond type. How can C bond with itself?
Think again.
Oh, I know. C can form diamond and graphite. So it must be network covalent.
You are correct. On to the next example. What about K2SO4?
Well, K is on the left side of the periodic table, and SO4 is a nonmetal. So it must be metal and nonmetal, which is ionic.
All right, this one may be tough. What about copper?
Well, copper on the periodic table is in the middle and is also a transition metal. And metallic bonds are bonds with only metals, so this must be a metallic bond.
You are correct. All right, let's try this one, SiO2. It may be kind of difficult.
Well, Si and O2 are both nonmetals because they're on the right side of the periodic table, so they must be covalent, right?
Well, actually, silicon is a metalloid because it's on its ladder. And we learned before that network covalent bonds are usually formed by diamond, like the carbon, and silicon. And silicon is one of our elements here. So this is actually network covalent.
Wow, you are correct. This one should be kind of easy. What about nickel?
Nickel is a metal, so it should be a metallic bond.
Yes, you are correct. Let's try methane, CH4.
Well, carbon and hydrogen are both nonmetal, and even though this compound has a carbon in it, carbon isn't bonded with itself. It's bonded with hydrogen, so it must be a covalent bond.
In addition, the electronegativity difference between carbon and hydrogen is less than 0.5.
So then, it must be nonpolar. All right, last but not least, let's try NaCl, salt.
Well, sodium is an alkali metal and chlorine is a nonmetal, so this must be an ionic bond.
Mm-hmm, you are right. Oh, I hope you guys learned a lot about bonding today. The 4 different types and what polar and nonpolar means. Catch you guys next time on Andrew Does Science. See y'all later. Check it out.